Talking about education, that's an interesting one because we've been focusing on large classes, but my education classes are smaller, but I used to do a biology methods course. And the normal thing is when you come to a class the first day, you get to know the professor, they talk about, course outlines, examinations, and this is the textbook. When my students came in for my biology methods class, they would see me standing at the front and there'd be instructions on the desk. And I would say, okay, welcome. What I want you to do is to read the instruction, get into the group of 3 that you're on, and perform this experiment. And there's a sort of, we don't do this. We just sort of come in, you tell us something. And they get right into it, and then it goes on for a double period. The third period then, next time I meet them, I say, why do you think I did that? And they begin to think, well, wait a moment. Rather than you talk to us, we did the work, good. We got to know each other because we're in groups, good. It was a social thing that we did in fact work cooperatively. And also they then realised other things. They got to do a bit of mathematics, they had to do some measurement, and biology is a science. It's activity based. And they come up with 18 or 19 things, and then they quickly realise the whole point of the exercise, but they did it all themselves. I hardly ever say a word the first time. I also get them to put up the results on the board to show how important it is to have group work and to see everybody's contribution on the board, and they have to work out the averages of the whole. And that works really well. Coming back to with the large classes, you have to be very careful. You have to pose very important questions, ones that don't have a yes or a no, but on the other hand can be answered. So for instance, the first class they come to, we're talking about, I won't say it's truth, but science is fact, what they read, and whether everything you read is true. So, and whether it's a good experiment that's being reported. So there was an article that came out a few years ago in one of the scientific periodicals, and I've condensed it. And then I go through it, and I say to them, in groups, small groups of 2 or 3, I just want you to discuss what do you think the important points of the experiment were, things that you think were covered well in terms of controls, things not, and whether you think the conclusion was correct. So I give them 3 questions they have to answer, and then I give them maybe 5 or 6 minutes to discuss, and then I'll stop the discussion. Now, with 200, and you've got groups of 3, there's no way you can get around everybody, and I recognise that. So then I'll go to this group over here, this quadrant, and I'll say, okay, somebody here got an answer. So eventually somebody will offer an answer, and I'll write that on the board, and then maybe another group from that area, right, and then move over and do it that way, so that those who want to contribute can, but they've all discussed it. And then what we will do is go through all the possible things that people have said, and then we'll come up with what on the whole seems to be a sort of a reasonably accurate answer to the questions. And then maybe we can continue it a bit further, depending on how it goes. What sort of things would you do to change that? So that they've got very specific things to do. You're not asking to solve major problems, but it does give them the opportunity to discuss things. And by doing it right off the bat, the first class they come to, basically first or second, it gives them the idea that this is the way these things will go. Later on it might be, one of the things about biology, it could be a genetics problem, or it could be something like that related to disease transmission. So that in fact, to say, they've got to be well defined. You don't want to take an enormous amount of time because then it gets boring for them. So 5, 6 minutes maybe discussion. It gives them the opportunity to solve. You're putting them in the position of being a scientist. Okay, here's a disease. This is the way it seems to work. What can you elucidate about it? Talk about it. And then later on the course, of course, we've been talking about antibiotics, and you can say to them, okay, given this particular disease and its transmission, what would you expect as a way, if you were a doctor and somebody came to you and presented that, how would you deal with it?